Imagine a sliding door opening as you approach, or a homemade radar scanner sweeping a room that stops dead when it spots an object. How exactly do all these separate pieces, the motors, the lights, the sensors, know how to talk to each other and operate perfectly on cue? The answer is usually a tiny blue board called an Arduino. This board is a microcontroller, a specialized mini-computer designed to handle specific, basic tasks. You can think of it as the conductor of an electronic orchestra. A conductor standing alone on a stage doesn't make any sound, but if you give that conductor musicians, your physical components, and a piece of sheet music, your computer code, they can orchestrate complex interactions. An Arduino is a bridge. It takes the ideas in your head and translates them into physical, interactive machines you can actually touch. Let's look at the physical board. If you ignore the complex-looking metal shapes in the middle, you'll notice rows of small holes running along the outer edges. These highlighted rows are called pins. They are the only way our conductor can communicate with the outside world. First, there are input pins. You can see here how the signal flows from an external button into the board. This is how the Arduino listens to the world, waiting to see if a button is pressed or checking the current temperature. Then we have output pins. Notice how the arrow now flows away from the board to light up a bulb. This is how the Arduino commands the world, sending out electricity to turn on a light or spin a motor. To use these pins, the Arduino speaks two different languages. The first is digital. A digital signal is either entirely on or entirely off. It works like the standard light switch on your wall. The second language is analog. Instead of just on or off, analog deals with a continuous range of values. It functions like a sliding dimmer switch, where you can set a light to 10%, 50%, or anywhere in between. These pins are the foundation. Once you understand how they handle signals, you have the interface to send data and receive a physical response. To write our sheet music, we use a free program called the Arduino IDE. The language we type into it is a simplified version of C++. A single program for the Arduino is called a sketch. To make a sketch work, you only need to understand two main sections, the setup and the loop. Here is the setup block. Any instructions you put in here will run exactly one time when the board turns on. This is where you organize the stage, like telling the Arduino that pin number 13 will be an output. Once the setup is done, the program moves to the loop. As you can see by this circular path, this is the actual performance. Any instructions placed inside the loop will repeat over and over again until the power is cut. To make a light blink, we place an instruction inside the loop telling the board to send electricity to pin 13 to turn the light on. Next, we tell the board to wait for 1 second, then tell it to turn the light off and wait 1 more second. After that last step, the loop simply starts right back at the top, and the light comes on again. Coding in Arduino is simply about giving your conductor a list of clear, chronological instructions to follow forever. With the code written, you click the Upload button on your computer. The instructions travel down a USB cable and are stored directly in the Arduino's brain. The second that upload finishes, the board springs to life, and the tiny built-in light on the board starts to flash on and off, keeping the exact rhythm of your code. To build larger projects, you connect the Arduino to external components using jumper wires and a breadboard. This grid makes it easy to plug in larger lights, motors, and buzzers to your pins. That reaction speed game from earlier works the same way. It reads an input from a player's button, waits for the code to process the timing, and then triggers an output to ring a buzzer. Building custom electronics doesn't require an engineering degree. All it takes is a basic starter kit, a digital conductor, and the curiosity to tell it what to do next.